All right, so today we're going to cover benchmarks AR 2.4, which is given a table, equation, or written description of a linear function, graph that function, and determine and interpret its key features. We're also going to learn about AR 2.5, which is solve and graph mathematical and real-world problems that are modeled with linear functions, interpret key features, and determine constraints in terms of the context. So these are both in Module 3, Lessons 1 and 3. Okay, you should have 4 pages of notes. If you don't have the notes, you should be able to access them in the first page in the module. All right, so graphing linear functions by using tables. A table of values can be used to graph a function. Every ordered pair that makes the equation true represents a point on its graph. So a graph represents all of the solutions of an equation. Okay, so that's why we can use tables and how we can use tables to graph a function. So in this example, we're going to graph by making a table. We have the equation negative 2x minus 3 equals y. Our first step is going to be to substitute each x value into the given equation. So instead of having x in the equation like it's given to us, we're going to substitute in these x values. First one is negative 3. Next is negative 2, negative 1, 0, and 1. Once we've substituted in those x values, then we're going to find the solution or the y value. And to do that, we just have to evaluate or simplify the expression. So first we have negative 2 times negative 3, which is 6. And 6 minus 3 is 3. Negative 2 times negative 2 is 4. 4 minus 3 is 1. Negative 2 times negative 1 is 2. Minus 3 is negative 1. Negative 2 times 0, of course, is 0. Minus 3 is negative 3. And negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. Then we're going to list the x and y value as an ordered pair. So any of my y values that are in green are now going to be listed as an ordered pair. So negative 3 and 3, negative 2 and 1, negative 1, 0, negative 3, and 1, negative 5. Finally, our last step is to graph the ordered pairs and connect it with a line. So just having ordered pairs does not make it a linear function. We have to connect it and do that final piece by making a line. So first we're going to graph negative 3, 3. So we're going to go negative 3 on our x-axis and up 3 on our y-axis, and there is our point. Then we're going to have negative 2, 1, negative 1, negative 1, 0, negative 3. So we're on our y-axis because our x is equal to 0, and negative 3 is going to be right there. And then we have 1, negative 5. So we're going to go across 1 on our x-axis and down 5 on our y. Once we have all of our points listed and graphed, we connect them with a line. Okay, now you're going to go ahead and check and try this on your own. So go ahead and pause this video a moment. Try this problem and graphing it on your own, and then restart the video to see if you got it correct. Okay, there are your answers. So we plugged in negative 4, negative 3, negative 2, negative 1, and 0. Once we did that, we got the point negative 4, negative 3, negative 3, negative 1, negative 2 and 1, negative 1 and 3, and 0, 5. Okay, now we're going to talk about example 2, which is making sure that we can choose appropriate x values or domain values. Remember, x values, domain, input, independent variable, all represent the same thing. They are all talking about x values. And so here we need to ensure that we are selecting the best x values so that we get a whole number. Okay, so in order to get a whole number, we have to think of multiples of 4 because 4 is in our denominator of this fraction. So if we have a fraction for a coefficient, we need to use multiples of 4 in order to get whole numbers. So first we're going to plug in -8 and then -4, 0, 4, and 8. And we're using those because by multiplying my 1/4 times these x values, I'll get a whole number and it'll be easier to graph. So 1/4 multiplied by -8 plus 3, that becomes -2 plus 3, and -2 plus 3 is 1. So I have -8 and 1, and then I can graph my point. Even though 1 is not listed on my y-axis, I can just go halfway between 0 and 2, and I have 1. Next, I have -4 for my x value. 1/4 of -4 is -1. So -1 plus 3 is going to be 2. So I can graph the point -4, 2. Next, I have 0. 1/4 times 0 is 0 plus 3. 0 plus 3 is just going to give me 3. You'll notice you're starting to see a pattern here in your y values. 1/4 times 4 is 1. 1 plus 3 is 4. So we're at the point 4, 4. And finally, we have 1/4 times 8 plus 3, and that's going to be 2 plus 3, which is 5. And there's my point. I connect the points with a line and graph. Now you're going to go ahead and try check for this, making sure that you choose appropriate x values so that you get whole numbers. Hint, you can either look at your x-axis and see what's listed there for x values, or look at your denominator, which is 3, and you're going to want to select multiples of 3 so that you get whole numbers, which are easier to work with than fractions. So hopefully you've paused the video. Go ahead and try this on your own and then come back and check your answers. Okay, so you'll see that I use these x values for my input, which I have -6, -3, 0, 3, and 6. So when I do 2/3 of -6 minus 2, I get -6. So I go to the point -6, -6, and graph it. 2/3 of -3 minus 2, I get -4. So I'm at the point -3, -4, graph that point. 2/3 of 0 minus 2, and I get -2. So the point 0, -2. 2/3 of 3 minus 2 is going to give me 0 because 2/3 of 3 is just going to be 2. 2 minus 2 is 0. So I'm at 3, 0, which is my x-intercept. And finally, I'm at 2/3 of 6 minus 2. And there I have 6, 2. Then I'm going to connect my points and I get my line. Okay, another way that you can graph linear functions is by using your x or y intercepts. So remember from module 2 that our x-intercept is when y is equal to 0, and that our y-intercept is when x is equal to 0. So we're going to use that knowledge that we've learned previously and apply it and use it for graphing. So here we have the equation x minus 2y is equal to -8. Okay, so to find our x-intercept, we are first going to let y equal 0. And so x minus 2y, or x minus 2 times 0, is equal to -8. Well, I can simplify that just to be x is equal to -8, which means the graph intersects the x-axis at -8, 0. So here's my x-axis. I'm going to go to -8 and graph my point. To find my y-intercept, we're going to let x equal 0. So when I plug in 0 for x, I get -2y is equal to -8. We're going to then simplify that to get -2y equals -8. Divide both sides by -2, and y is equal to 4. So that means that it intersects the y-axis at 0, 4. There's my y-axis. There is 4 on my y-axis. Now I can connect the points and graph my line. The check, I still encourage you to try on your own. However, I do acknowledge it is a little bit more difficult than the one we did in the example. So if you are stuck, just follow along. First, we're going to plug in 0 for our y. 4 times 0 is equal to negative 12x plus 36. And then we're going to plug in 0 for our x. So 4y is equal to 12 times 0 plus 36. In the equation on the left, we end up with 0 equals negative 12x plus 36. Well, we have to get our variables on one side and our constants on the other. So I thought that the easiest way to do that would be to add 12x to both sides. So 12x is equal to 36. Then I'm going to divide by 12, and x is equal to 3. So that means that my x-intercept is at 3, 0. And I can go ahead and graph that point. Now I'm going to graph my y-intercept. When I plug in 0 for my x, I'm going to get 4y is equal to 12 times 0 plus 36, which simplifies to be 4y equals 0 plus 36, which means 4y is equal to 36. Divide by 4 on both sides, and y is equal to 9. So my y-intercept is at the point 0, 9. Then I can graph that point, connect the dots, and graph my line. Now I want you to go ahead and complete the practice problems, first on the piece of paper and then in the PowerPoint assignment in Canvas.